Let's talk conditions now. First question, there is a strategy that we're going to use now, and I want to see if you can recognize how close it is to our strategy from the previous video. Highlighting, drawing a border around, and counting. The second one is, how is this question D, different from our work in question C? So, our scenario, rolling a 5 first and getting a sum greater than or equal to 8. So our notation here is now the idea of given, and I want to call given as a vocabulary word to your vision. Given is our focus. Shade the desired outcomes and draw a border around the possible outcomes. Because of our structure of B given A, I should say it with the entire phrasing. The probability of getting a sum greater than or equal to 8 given rolling 5 first. Instead of it being the entire sample space, now we're only focused on rolling a 5 first. There are 6 of them. And of those 6 5 first scenarios, 4 of them have a sum of 8 or greater. So there's our probability. The probability of B given A, the probability of rolling in a sum of 8 or greater, given you rolled a 5 first, is 4 out of 6. Kind of likely. 4 out of 6 is greater than 50%. Let's compare that directly to the probability of B. A reminder, B is a sum greater than or equal to 8. So in our previous page, when we talked about rolling a sum greater than or equal to 8, it was all of these. There were 15 of them. So the probability of rolling a sum of both dice greater than or equal to 8 was 15 out of 36. But what we just saw right now is that a sum of 8 or more, given we rolled a 5 first, is 4 out of 6. Now they don't have a common denominator. That's an easy fix. Multiply both top and bottom by 3. And now we can compare, since their denominators are the same, that they have different numerators. Which means that A and B are not equal, since A is not equal to B, this is a dependent situation. Yeah, you could roll a 5 first and then conditionally roll a sum of 8 or greater because you started with 5 first. It's a higher likelihood of that happening. So the key thing I want to make sure is brought to your mind. This method of looking at the total number of outcomes, which at the given condition, it's certainly less than the entire sample space. Question D right here. The sample space with the given condition means we have a smaller population of numbers we're looking at. So it's going to be a different value likely. Typically will be a different population from the entire outcome. The scenario that we compare it to, reminder, just one thing. If we have a given formula and we compare it to, let's B, right? It's both of these that are the structure. If that's a B situation right there, then this has to be the B situation there. And if they're not the same, they're not equal, then you have a dependent situation. So thank you for watching this conversation around how we can tell whether or not two events are independent or not. This is how. This is what given condition looks like. It's not the entire table. It's just one section of the table. Thanks for watching. See you on the next one, 8:50. Let's go.